Everyone. In this video, we are going to learn some definitions, postulates, and theorems related to angles that we will be able to use in proofs. Now, some of these are going to seem a little bit familiar because you learned about them in the previous video. So first off, we have our properties of equality and our properties of congruence. These are the exact same things. These things can be used when you're talking about angles, segments, shapes, triangles, quadrilaterals. These statements will still hold true. So we're going to move on to some of the new statements. The first we have is our definitions. Our definition of congruence was that statement that lets us go back and forth between the measurements are equal and the angles are congruent. So remember, these are the shapes. These are the measurements. And then these are the angles, the shapes. And so our definition of congruence lets us go back and forth, which is how we're going to be able to set up equations. Now our new definition is an angle bisector. So an angle bisector, the word bisect, we see that word bi, or that prefix bi, which tells us two, and then bisect means to cut into two parts. So an angle bisector divides an angle into two equal parts. We also know the definition of complementary and supplementary angles. So in a complementary angle, the sum is 90 degrees. Ideally, this term should be familiar. We know complementary means they add up to 90, and supplementary means they add up to 180. So if you know that the angles are 90 degrees, then you know they're complementary. If you know they add up to 180 degrees, you know they're supplementary. This arrow tells us the statement could go start here and here, or start at sum, end at complementary. Our next definition is the definition of perpendicular. So perpendicular lines form four right angles. The symbol for perpendicular, or that's the symbol for right angles, the symbol for perpendicular looks like an upside down T. So you have a vertical line and then a horizontal line. So that's our symbol for perpendicular. And it tells us that they're lines that cross at four right angles. And we know a right angle, which I can represent using that little box in the corner. A right angle is 90 degrees. So these are all some terms that hopefully are familiar, but it's very important that we understand the key differences between what perpendicular is telling us versus right angles, because when we go to write a proof, we are going to have to be specific here. We also have some postulates. Our angle addition postulate is the one that tells us that we can add up two angles that are next to each other to give us the entire angle. So if we have this picture right here, I have A, B, D, and C. I can add up the two small angles to give me the entire angle. This is one that we did already learn. You notice that this postulate has to do with equal signs, right? Because measurements are numbers. Our last portion are our theorems. I want you to remember that a theorem is something that has to be proven first. So all of these statements have been proven before. So we will be going over some of these proofs in class together, but right now I want you to be familiar with the vocabulary. So we have vertical angles, and you might be familiar that a vertical angle are two angles that are across from each other at an intersection. So here and here. And if you have vertical angles, then they are congruent. Vertical angles are congruent, and that is our vertical angles theorem. We also have our complement theorem, which is if two angles form a right angle, then they are complementary. Which should make sense, because we know that a right angle is 90, and if we know they add up to 90, then we know they're complementary. So what we're doing is we're going in a sequence. We're starting at right angle, going to 90, then going to the term complementary. The same thing happens for supplementary. So a linear pair is something that looks like this. So they make a line versus making a right angle. And if they make a line, then they must be supplementary. This supplement theorem can also be called a linear pair theorem. Depending on the resource that you look at, you might see it called different things. And our last two theorems, the congruent complements and the congruent supplements theorem. I'll first read it and then we'll show what that looks like. So if angle A is complementary to angle B, and angle C is complementary to angle B, then angle A is congruent to angle C. For the congruent supplements theorem, if angle A is supplementary to angle B, and angle C is supplementary to angle B, then angle A is congruent to angle C. So the only difference here is between the two words. So let's look at the congruent complements theorem. So I have angle A is complementary to angle B. So that tells me by complementary that the measure of angle A plus the measure of angle B has to be 90. Now I also know that angle C is complementary to angle B. Well, that tells me that the measure of angle C plus the measure of angle B equals 90. Now these two statements look very similar, right? I've got measure of angle A plus measure of angle B, measure of angle C plus measure of angle B. They're also both equal to 90, so I could use substitution or the substitution property of equality to say measure of angle A plus the measure of angle B equals the measure of angle C plus the measure of angle B. So all I did was say, oh, well, these are both equal to 90, so they can be equal to each other. And then I could subtract the measure of angle B on both sides. So that cancels out and that cancels out. And we're left with the measurements of the angles have to be equal. Now that makes sense because if I know that angle A plus angle B is 90, and I know that this one is 30, well then doesn't this have to be 60? Same thing if I have this angle C plus angle B, well angle B is still 30, which means that this is still 60. So from a numeric side it works. And then this is actually a proof. This is a proof that angle A is congruent to angle B because I showed that because I knew what their measurements were. So that's our congruent complements and congruent supplements theorem. It just means that if they're complementary to the same angle or supplementary to the same angle, then they have to have the same measurement, and that means they have to be congruent. Make sure that you are familiar with the vocabulary that has been used in this video and read through it again if you need to. In future videos, we will learn how to turn these theorems into full proofs. Thank you for watching.